In this demonstration of the analytics monitoring platform, we're going to look at how to create some real-time flow monitors using AMP and the Brocade Network Advisor management software. So we're going to start off by finding the 4 applications that we want to create these monitors for. These are all sitting behind a single ESX cluster. They're VMs in an ESX cluster identified as VMs 73 through 76. Now, for the ease of this demonstration, we've put all 4 of those VMs behind a single HBA, and we can see here the specific HBA that these VMs are associated with. Now, the targets for these 4 VMs are on 2 different target devices. We've got a read and a write going to ones 0 and 1 on the first target device, and a read and a write going to ones 0 and 1 on a second target device. Now we'll kind of take a look at the topology view in Brocade Network Advisor. You can see here this is the fabric that we're working with. We've got an AMP here connected up to 3 different switches. There's a 4th switch that's unrelated for this demonstration. The initiators, the virtual machines, are sitting behind the HBA attached to this first switch. The first target with 2 of the ones on it are on the switch to the top right, and here on the top left we have the second target with the other 2 ones. Now we've actually already configured up the virtual taps on each of these switches connected to the analytics monitoring platform. This allows us to monitor at both the initiator port side as well as the target port side. This is also called dual tapping or double monitoring. We're going to go ahead now and take a look. We're going to go in on the AMP. We're going to drop down using a right-click menu option to Fabric Vision, Flow, and Monitor. And in doing that, we get the full Flow Vision, Flow Monitoring dialog. Now, all the different Flow Vision flows are defined in here, but we're going to take a look specifically at the flow on the AMP. So we're going to highlight that flow, and we're going to push it over to the right side to take a look at what's been learned. So by pushing that over now, we're going to be just looking at the flows on the AMP itself, and here we can see all of the flows that have been learned and are now being monitored by the AMP. Now, one thing that's a little bit different here versus previous versions of BNA for Flow Vision is the ability to have multiple pages. So because of the fact that an AMP can have up to 20,000 flows it's tracking, we now have the ability to kind of flip through multiple pages and specify the number of flows per page that we're viewing. So here we're viewing 25 per page. Now, instead of trying to look through all of the flows that are displayed, we can filter this down, and you'll notice these new drop downs here on each one of the columns. We can basically go, since we know the source port that we're looking for, we can specify the source by putting in the port ID or the SID, the source ID, for the port where our VMs were coming in, the HBA port they were coming in. So we're going to specify that, and now we see just 12 flows total. Now, why do we have 12 flows when there were 4 different VM flows that we were looking for? Well, basically, the reason for 12 flows, there are 4 initiator target 1 flows on each of 2 ports that are being monitored. So you've got 4 ITLs plus 2 ITs on the host port and the target port for a total of 12. So now we're going to go ahead and pick one of the initiator port flows, and we are going to go into the performance graph, and we're going to create a real-time graph. If we select that now, we've got a whole bunch of different metrics now we can choose from. We've got all the new I/O level metrics, including latency and performance. So we're going to select a couple of those. We know the data size that we were doing for these reads and writes, so we're going to select read completion times and our read first response time, as well as a couple different performance metrics. So we're going to look at the data rate and the IOPS rate for the reads here. So we select each of those metrics, push them over onto the graph, and then it's going to start plotting those on a 1-minute interval time period. Now, we could close this out, but we want to actually save this. So we're going to actually save this to our custom dashboard. We're going to put a name in for it. We're going to specify the particular VM, and we're going to save that off. So we know which VM we selected there at the beginning. We'll put that into the name, and then we will tell it OK, and that's going to basically publish it to our dashboard. So we'll finish that up. And then we would go back in and create another performance graph for each one of the other flows. Now, for sake of time, we're actually not going to go in and create each of those different performance graphs, but we would have gone in and kind of replicated what we just did. So we'll skip showing that, and we're going to jump right to the dashboard that we would have created if we had gone through each of the additional ones. And that's what we're looking at right here. So now you're actually seeing 8 different performance graphs. Each pair of these is one of the VMs. The top graph on each one of the pairs is from the initiator port. The bottom graph is from the target port. So it's the same flow, but on the top viewed from the initiator port perspective, and at the bottom view from the target port. So we'll go ahead and go in now and take kind of a close-up look at the metrics we've got for one of these performance graphs. We're going to pick that first VM73 at the initiator port. We're going to expand that out, and we're going to see a couple things here. So this is the read operations. Read data rate's about 34 megabytes per second. The first response time and exchange completion time are around 25 microseconds, and we're running at about 8,000 IOPS right now. We'll move over now and take a look at another one. This is write operations for VM74. We see a write data rate of about 765 megabytes per second. First response time, exchange completion time around 40 microseconds, and IOPS of around 3K. So right now everything's running pretty healthy. All the VMs are performing very well. But we'll go ahead and now introduce a slow drain initiator device into the fabric. Now when we do that, the first thing we're going to see here are a couple of alerts. So we've got our maps monitoring set up. So we're triggering now an I/O latency threshold on some of the flows on the AMP. This is an alert and a notification and monitoring that is occurring directly on the AMP device itself. And in fact, we're able to see every single individual I/O level violation that occurs. We can see the one, the source ID, destination ID, the exact flow itself, and we can see each of the I/O events that violated the threshold. And if we actually drill down into the maps log, we can not only see each individual violation, but the measured value. So if we had a particular threshold value set, we can see what the level was that exceeded the threshold. And again, you'll see that for each individual I/O. So very granular there. Now if we go back in and take a look at some of those graphs that we looked at before, so we're going to look at the initiator port. This was those read operations we were looking at before. Note now that our read data rate has dropped from 25 down to about 1 megabyte per second, and our latency has skyrocketed. So we've jumped up from 25 microseconds up to about 3 milliseconds. So we're up around an order of 100 times more latency here than we were running before. And our IOPS has dropped down to less than 1,000 right now, about 0.3. Now we're going to look at the same flow but at the target port. Here we see the read data rate dropped off 25 down to about 1. The latency though has not really changed. We're still at about 100 microseconds, up just a teeny bit from that 25 microseconds we were seeing before. So in general, the latency hasn't increased at the target port. So this is actually telling us that the target device is still behaving normally, that all the latency is coming between the initiator port and the target port or within the fabric. Here's the one of the other flows. This is one of the write operations on VM74. Similar, the data rate has dropped way down to 280. The latency is shot up from 40 microseconds up to 4,000 microseconds. And again, this is at the initiator port. So we are seeing a slowdown from the host port or the application side of the fabric. But if we look at, again, that same flow at the target port, you're going to see here the data rate, again it matches of course, but the first response time latency remains low. It's still right down there at a very, very low level. Latency completion time, these writes are a little larger, so we went up from 4.5 milliseconds up to 11 milliseconds, but the latency from the device is still very low. So that slow drain device slowed down our fabric, but we can see conclusively here that our target device, the storage device, really did not slow down significantly at all. So a couple of key takeaways here. First off, the ability to monitor at the target port lets us prove conclusively that the storage device was not a problem in this particular slowdown condition. We had a slow drain device in the fabric, and by looking at the performance behaviors and characteristics at the storage port, we could see that there was no problem with the storage device itself. However, the ability to monitor at the host port side, in addition to the storage port side, allows us to see that the performance issue was within the fabric. If we had not been monitoring at the host port side, you wouldn't have been able to conclusively determine that it was a slow drain device or some sort of performance problem in the fabric itself, because the problem could have been upstream within the HBA, within the adapter, and not necessarily within the fabric. But the fact that we were able to see the slowdown in the response time when we were monitoring from the host port directly allows us to see conclusively that the performance issue is in the fabric and not upstream northbound of the adapter connection into the fabric itself. So this is just one example of where the ability to view the performance characteristics and behaviors at both the host and the target port locations can be very valuable for conclusively showing what a problem may be, where a problem may be coming from within the fabric.